Hi, in this section we are going to talk about correlation. Correlation is the foundation of data science and machine learning. You keep talking about, when you talk about data science, about signals, about the insights, information, knowledge, all kinds of things. The basis of all of them is correlation. When you do machine learning, you are trying to predict something with some other thing. The thing you are trying to predict is the target. The thing you are trying to use to predict is called the predictor variable. And to predict the target, there has to be correlation between the predictor and the target. If you have correlation, you can use machine learning to predict. If you don't have correlation, then you can do nothing. Correlation is the foundation of data science, and let us try to learn something more about it. So what is correlation? Correlation is a mutual relationship or connection between two or more things. So there are two things which are represented by two sets of numbers. When you say correlation, it means that when one set of numbers, when the value goes up, the other also goes up. Or when the value goes down on one side, the value also goes down on the other side. So on the right side, you have a chart between blood pressure and age. And you see that as age increases, the blood pressure also increases or decreases. This shows a relationship between the variable age and the variable blood pressure. And this is what we call as correlation. When one thing goes up, the other thing also goes up. It shows interdependence between two sets of values, or the interdependence between two variables. So correlation, as we said again, is the correlation between two sets of data is how much one changes when the other also changes. How much one changes, how closely does one change when the other also changes. And it is the basis of data science. As I just explained, correlation is needed between the predictor and target variables in order for you to do accurate predictions. And here we saw an example of age and blood pressure. Measuring correlation. How do you measure correlation? There are a number of ways or measures that we have been using to measure correlation, but the most important and the most popular one is what we call the Pearson's correlation coefficient. We would be using this coefficient measure in all our examples in our predictive analytics modules. So please pay close attention to this. Pearson's correlation coefficient is a number that varies between -1 and +1. The closer the value is to -1, the more negative the correlation is. The closer the value is to +1, the more positive the correlation is. And the closer the value is to 0, there is no correlation. And the examples for them are actually shown in the various charts at the bottom. So suppose you take two variables and plot one on the x-axis and the other on the y-axis, and each data point and each example or sample is plotted here in this chart. When you say there is a perfect positive correlation or the value is 1, you see that as it increases, as the x-axis increases, y also increases in a really straight line. When the correlation is like 0.8, highly positive correlation, you see that they almost fall in a straight line, but there are little ups and downs somewhere. When you have a value of 0.3, which is low positive correlation, the values start spreading out, but they still kind of fall into a straight line, somewhat in a straight line, but there is a lot of variance. When there is no correlation, of course, the values are all over the place when the value is 0. A negative correlation is when one value goes up, the other goes down. That is what you call a negative correlation. One goes up, the other goes down. So the same plotting on the x and y, you see that when there is low negative correlation, the values are all over the place, but it is still somewhat falling into a declining straight line. When you move into a high negative correlation, it is almost a straight line, and a perfect negative correlation is a straight declining line. So this is how correlation between two sets of values can vary between one another. And it is important for you to keep plotting your data in these kind of charts and keep looking at them and seeing what kind of correlation I am seeing in the charts and what is my Pearson's correlation coefficient measure for each of them. One very important thing we need to realize about correlation is what is the relationship between correlation and causation. So correlation, as we saw, is that the relationship between two values. The causation is the reason for a change in value. You have variable A and variable B, and when variable A goes up, variable B also goes up. Does it mean that variable A is the cause of variable B? Let us take a simple example of the relationship between weight and cholesterol levels. You would typically see that as weight goes up, cholesterol levels also goes up. Is it a causation? Is weight a causation for cholesterol levels to go up? Yes, that is because it is scientifically proven that the more you weigh, typically the more fat you have in your body, and that means there is going to be a number of scientific reasons why you're going to be having more cholesterol. So there is a reason, there is an explanation for this causation, that when weight goes up, your cholesterol level also goes up. Let us ask the reverse question: is the cholesterol level the causation for weight? No. Just because your cholesterol level goes up doesn't impact weight, because scientifically it is proven it is weight which is impacting cholesterol, not the other way around, right? Let us take, so correlation may not imply causation. So that is another important thing. So just because two variables are related to each other, just because two variables, one goes up, the other goes up, does not mean one is a causation for other. Let us say another example of dress size. Okay, let us compare the dress size against cholesterol level. When your dress size goes up, typically your cholesterol level also goes up. Does this mean your dress size is the causation for cholesterol level? No. They are dependent, they are correlated to one another, but one is not the causation for other. They have actually a third cause, which is nothing but your weight. So weight is the causation. So there is a correlation between your weight and dress size, between your weight and cholesterol levels, and the weight is the causation that your cholesterol levels goes up and your dress size goes up. So correlation may be due to correlation between two variables, may either be due to causation, they may have a common cause like dress size, and cholesterol levels have a common cause like weight, or it can be just purely incidental. There might be no reason. So you have to, whenever you see correlation between two variables, you have to go and figure out why are they correlated with each other. Is there a causation involved? Is there a common cause involved? Or they are purely incidental? When you try to predict something in machine learning, you want the predictor variables to be the causation for the target variables. That is when the prediction will hold good in the future. When your predictor variables are the cause for your target variables, that is when your machine learning is going to be accurate. If that is missing, if the relationship is purely incidental, there is no guarantee that the correlation you see today will also happen tomorrow if the relationship is just incidental. So you want to always go and look at the reason why some two variables are correlated with each other when you are doing machine learning. So here is an example of a relationship between US highway fatality rates and fresh lemons imported to US from Mexico. An interesting thing you see is that as the fresh lemons imported from Mexico keep going down, it was lower, the fatality rate is high. So why is US highway fatality rate, death from road accidents, high when the imports to USA from Mexico is low? This is purely incidental. As you see, this is on a timeline, so there could be two different independent things that might be happening on this timeline, which is impacting both of them. But the US highway fatality rate has no relationship to the fresh lemons imported to US from Mexico. So even though you see a correlation here, there is no reason to believe that there is some relationship with each other. So you have to be very careful when you see correlation between two variables. You have to establish the ground truth as to why you see this kind of a relationship. So that completes our discussion on correlations. Thank you.